Welcome back to another one of my implicit differentiation videos. We'll be doing applications to graphs, and we're going to be finding the equation for the tangent line. This is the fourth episode, and let's get right to it. The examples I'm taking are going to be right out of this book, James Stewart Calculus, metric version, and it's going to be, the copyright is this one. Probably not going to focus, but it's Sengage Learning, or however you bloody pronounce it. I always get it wrong. But what we'll be focusing on is this question. It's called the Devil's Curve, as said here, and that's what we'll be doing. Okay. So I've got a blue pen because my black pen's starting to run out. Anyway, the Devil's Curve looks a bit like something along the lines of this. Here's your y, and this is your x. The point we're looking for is just at the bottom of this with coordinates 0, -2. Okay, so let's start. We have y squared multiplied by y squared take 4 equals x squared multiplied by x squared take 5. First step, we're going to multiply these out, expand them and we're going to get y to the power of 4 take 4y squared equals x to the power of 4 take 5x squared. Now we're going to find the derivative. I'm using quotation marks to signify everything above, or the next line above. Okay, let's get right into it. So, derivative of y to the power of 4 is 4y to the power of 3 multiplied by dy dx minus 4y squared is going to be, bring the 2 down, it's going to be 8 y multiplied by dy dx, because that's the derivative of y. That's going to equal 4x to the power of 3 multiplied by dx over dx, which is 1. I'm not going to bother writing that. We're far enough into this series that it should be force of habit by now. But this is going to be 10x, and that's going to be it. So, we can factor out the dy dx from each one. We're going to have dy dx 4y to the power of 3 take 8y equals 4x to the power of 3 take 10x. Okay, now what we're going to do is we're going to divide both sides by 4y cubed take 8y, and what that's going to give us is dy dx equals 4x to the power of 3 minus 10x over 4y to the power of 3 minus 8y. Okay, now that we have that, we're going to sub in our x and y coordinates, x being 0, y being -2, dy dx equals 4, 0 cubed minus 10 multiplied by 0 over 4 multiplied by -2 to the power of 3 minus 8 to the power multiplied by -2. Now the top is going to equal 0, and the bottom, it doesn't matter, because if it's a 0 on the top, it's a 0 altogether. So that means the m, which equals the derivative, will equal 0 at that point. Okay, so the equation is going to be y minus y1 equals m x take x1, y minus, the y is going to be -2, so that's going to turn this into a +2, equals m, which is 0, multiplied by x minus x1. Basically, this is going to equal 0, y plus 2 equals 0, therefore y equals -2. And that is the equation for the tangent line at that point. Thanks for watching. I hope you learnt something, and have a good day.